What's up, good people? Thank you for joining. Thank you for liking and subscribing in this video. So what I'm going to be talking about here, I'm going to be talking about 2D and 3 dimension of trigonometry. This is essentially an application of trigonometry. So if you want to understand how you can use trigonometry, this is it right here. So trigonometry is being used in so many things, but one of the amazing things here is actually able to calculate poles. Let's say you want to, in this case, you wanted to have a pole that will able to hold your national flag, a flag pole, and you want to have the strings that you want to attach to the pole. So in this case, you have this pole and you have the strings that are attached to the pole to hold it stable, and you have the ground of this is the ground and this is the pole and these are string attached. I mean, you can actually even calculate, can even use the same argument if let's say you have what you call electricity pole and you want to attach the strings to the pole so that you can able to transmit the electricity, and you can actually essentially use the same analogy of trigonometry. So trigonometry is being used in different cases, and in this case you're going to be learning about trigonometry and how you can actually use that and do your calculations and find solutions, right? And it's very important to be accurate in your angles, to be accurate in your in your distance, to be accurate in your sides, whatever that you're trying to build. So we're gonna go and dive deep into that. We're using question 7 from November 2022, paper 2, grade 12 past paper. So let's go. In AB, so they tell us we have AB. AB is a vertical flagpole that is square root of 5. So AB, that's a vertical flagpole square root of 5 meters long. And you have AC. AC, that's an AC. And you have AD as well. Are two cables anchored the flagpole, as I've mentioned. And you have you have B, C, and D. So we have B, C, and D, and in the same horizontal plane. So that's your ground. And BD, where's BD? BD is 2p meters, and angle ACD. So this is how you read this, right? So that cap over there means angle. So the way you read this to say angle ACD, right? So angle ACD, so say angle ACD. So they're looking at this angle here. This angle is X. And again, this is how you read this because of that cap there. Angle ADC. Angle ADC is 45 degrees. All right. So we have all the information. And what they want us to then do is to determine the length of AD in terms of P. Determine the length of AD in terms of P. So where is AD? And if you look closely, AD is this here, right? What do we know with AD? You know AB. So you know AB is square root of 5, and we know this is actually a right angle triangle, and we have AD here. So it seems like this AD is a hypotenuse of a right angle triangle. So you can actually use Pythagoras to actually calculate AD. So let me just zoom it in. So you have a triangle, and this is A, and this is B, and you are being told AB is square root of 5p, and you have D, and BD is 2p, right? So they want us to determine the length of AD in terms of P, right? So meaning our AD is going to be in terms of P. So the way you would do this, you just use Pythagoras theorem. So the way you use this Pythagoras theorem, we know that, just quick revision to those who don't know Pythagoras theorem. Pythagoras theorem says that if you have a triangle, and it should be a right angle triangle, and you know the distance of this triangle, and you know the distance of AB is R, and you know the distance of AC maybe is Y, and you know the distance of CD is X. So the Pythagoras theorem says that R squared is equal to X squared plus Y squared. So this is Pythagoras theorem. So we can actually use this argument again into to our advantage. So saying that we don't know the distance of AD, and that's what we are looking for, right? But we know that AD squared is equal to AB squared plus B D squared, and likely we know that AD is actually square root of 5p, and we know BD is actually 2p, right? So then from here we can actually simplify this for a quick revision again. So if you have AB squared, this will be equal to A squared times B squared. So we're going to use that knowledge here. So this is going to be square root of 5 squared P squared. This is going to be 2 squared P squared. Okay. And again, square root of A squared is equal to A. So we're going to use that information as well here. So this is equal to 5 P squared. This is equal to 4 P squared. And 5p squared plus 4p squared, that is 9p squared. So AD squared is equal to 9p squared. So this implies that AD is equal to, if you put a square root on both sides, so your AD is equal to square root of 9 and square root of p squared. So we know, again, what we have done here, if you have a square root of A, or rather AB, this will be equal to square root of A times square root of B. So that's what we're doing here. So, and then you're going to end up with square root of 9 is 3 and square root of P squared is P. Because we already know this, that square root of P squared is P, or square root of A is A. So AD is equal to 3P. So that's your answer. And then you get like 2 marks. So you get a mark for that and a mark for correct substitution in your Pythagoras theorem. So, right. So let's come back and just write that down here. So this is 3p. And let's go to 7.2. So if you don't know, if you have a question here, please let me know. I'm happy to help. Just type it up on the comment section. And yeah, so I'm happy to, if you like this, don't forget to like and subscribe. 7.2, show that the length of CD is equal to 3p sine x plus cos x over root 2 sine x. Okay, well, where is CD? So if you look at this, you see that CD is here. So that is your CD. I mean, you have 3p. What else do you have? You have these 2 angles here. So if we look at this triangle, if we zoom into that triangle, so let's zoom into that triangle real quick. All right, so let's get it. So 7.2, show that the length of CD is equal to this expression. So to able to do this, right, you need to understand a couple of things, right? So I'm going to just take you through it before we do all the magic. So I'm going to take you through the cheat sheets. So let's, first thing first that you need to understand is the cast diagram. As always, you need to understand the cast diagram, that on the first quadrant, all are negative, all trig ratios are positive. On the second quadrant, only sine is positive. On the third quadrant, only tan is positive. On the fourth quadrant, only cos is positive. And you need to also remember this one here. If you have a right angle triangle where there's 45 degrees, this is going to be 1 and 1 is square root of 2. And if you have, what else that you need to know? So if you have, yeah, so also I want you to remember this. Sine A plus B is equal to sine A cos B plus cos A sine B. Right, so that's another thing that you need to remember. What else do you need to remember? Let me think. What else do you need to remember? Pretty much, yeah, pretty much this is a thing that you need to remember. If there's anything else that comes, I'll let you know, but this is pretty much things that you need to remember to be able to solve this problem. So let's go into it. So show that the length CD is equal to that. So if you look at CD, this is CD, and you have this. as well as CD. So essentially they are looking at that triangle. So if you zoom into that triangle, so this is A, this is C, this is D. So you got 3p there. That's what you got on the first question. And you got an X that's given, and got 45 that's given, right? And then from here we're gonna use another information that we need to quickly check to use is this one here. So if you have a triangle A, B, C, and that triangle here, you can use this information. It says AC over sine of angle A, this angle here. Alright, let me put it this way, not like that though. So angle, so if you know this side here, BC, side BC is over sine of angle A is equal to side AB over sine of, so this is that, over sine of C, and also is equal to AC over sine of B. So that's also another knowledge that you're going to be using to solve this. So looking at this, right, we know we have ADC, right, triangle ADC, and we have X, we have 45, we have 35, and we're looking for that. So using that information, so we can say, okay, cool, with CD over sine A, we can actually find it if we know AD, right? So we know AD over, and we know C as well is X, which is cool. So we don't know CD, and the problem is we don't know A as well. So we don't know what is A, but angle A, we don't know this angle, but we know AD. AD is 3p, and we know C as X. So first you need to identify what is A. After identifying A, then you can identify what is CD. So to determine A, we need to then know that the sum of the triangle, the sum of angles within a triangle are equal to 180. So meaning if I add these two angles together, they should give me 180 all the time. So the sum of the angles within a triangle, they should give 180. And then from here we can actually solve for A. So it's going to be 180 minus 45 minus X. So I'm taking X plus 45 to my right hand side. So it becomes 180 minus 45 minus X. So this is going to be 135 degrees minus X. So A is 135 degrees minus X. So therefore, CD over sine A, and A is 135 degrees minus X, equal to 3p over sine X. And you can essentially say, okay, so CD, if you cross multiply, is going to be 3p times sine 135 degrees minus X over sine X. Okay. Let's go back to C. So we got 3p there. That's good, but we don't have that. We have sine X there. That's fine. So how do we then do this? We come back into, we then use compound angles to actually simplify this expression, right? So if I take you deep into this rabbit hole, so you have sine 135 degrees minus X. This can be written as sine 135 degrees cos X minus cos 135 degrees sine X. Okay, that's how you write this. And sine 135 degrees is essentially, we look at where is this. So what we've done is we've used this one here. So sine A plus B is sine A cos B plus cos A sine B. So in this case minus, so that's why you have a minus there. So it's sine 135 cos X, cos 135 sine X. And then from here, what you then say, okay, cool, you ask yourself, your question is, where is 135? And 135 on the Cartesian plane is on the second quadrile. And on the second quadrile, only sine is positive. So you're right. Okay, cool. This is sine, so I'm writing sine. Sine is positive, right? Positive sign. And then you reduce that 135 into your first quadrat. So you're going to say 180 minus 135. So you're going to get 45 degrees. So it's going to be 45 degrees times cos x. And again, you do the same calculation. Where is 135? 135 is on the second quadrant, and it's on the second quadrant. Only sign is positive, so therefore our cos is negative. So you're gonna have negative. You write negative cos, and then you say then 180 minus 135. You got 45 degrees sine x. Okay, and as you have guessed it, not even guessed it, you've calculated it, that negative and negative cancel, become positive. So you're gonna have plus cos 45 degrees sine x. And this is what we know. Then you're gonna use this right angle triangle, right? So we know that sine 45 is opposite of adjacent. Maybe I need to write that. We know that sine is opposite over hypotenuse, and we know that cos is adjacent over hypotenuse. So we're looking at that. We say, okay, cool. Sine 45 is opposite over hypotenuse, and the opposite side of 45 is 1. So it's going to be 1 over hypotenuse with square root of 2 cos x. And cos 45 again is adjacent, and adjacent side of 45, the adjacent side of 45 degrees is this one, and so you're going to be 1 again over square root of 2 sine x. Right, I mean, you can actually figure that out. This is going to be, if you figure it out, it's going to be cos x plus sine x. Right, so we can actually then write this like that. So and say, okay, cool, this is going to be 1 over root 2. Can you just write sine x cos x if you want to, it doesn't matter, divided by sine x. And this can be written as 3p sine x plus cos x divided by square root of 2 sine x. That's basically that's your answer, and that is what you are asked to prove. Right, so if you have a question on this, let me know. But you're gonna get a mark for that. You're gonna get a mark for this, and you're gonna get a mark for correct substitution. There's 4 marks, right? 3 marks, 5 marks. Okay, good. That's good. And you're gonna get a mark for this, or rather, you're gonna get a mark for that, and you're gonna get a mark for so you're gonna get a mark for going there, doing that, and getting a mark for getting 1 over root 2. So that's where you get your 5 marks. Okay, so if you have a question on this, let me know. I'm happy to jump back and help out. But yeah, so let's go to 7.3. So they say here, if it's theta, let's see what you have. Okay, we have CD here. Yeah, cool. We have CD. So if it's theta, given that P is 10 and X is 110, calculate the area of ADC. So they tell us now that if you come here, you know, CD is this thing here, 3P sine X plus cos X over square root of 2 sine X. That's given, and we know AD is 3P. So within this triangle here, let me bring it bigger one, within this triangle here. Okay, so in this triangle here, sorry about that, but within this triangle here, and they tell us that P is 10 and X is that, calculate the area of ADC. Right, so to able to calculate the area of something, of a triangle, any triangle, I'm going to be using this formula. So this formula says a triangle, we have a triangle A, B, C, and the formula says, let's say you have a triangle A, B, C, and it's going to be half of, depending on what you know. So let's say you know this angle here, angle A. So you're going to take this side and that side. So you're going to take AB and A times AC, and then you say sine A. That's angle A. So that's basically how you calculate it. If you know this side, you're only going to take AC and BC. If you know this angle, sorry, then you're gonna take AD and BC. So that's depending on which angle you know, right? So in this case, we know two angles, right? What do we know? We know this angle here and we know this angle here. So we know two angles and we know two sides. These are guaranteed side, this and this one, right? So therefore, we can just take 45 degrees, right? You can just take 45 degrees and use this two side to find the area of this triangle. But to do that, we need to then substitute. Where there's P, you put 10, and where is X, you put 110, and just do your calculation, right? So, I mean, this is equal to 3 times 10, which is 30. So your AD is 30. And here, if you do your calculations, you can bring on your calculator. Boom. Got my calculator. So on my calculator, what I would need to do is just calculate this length of CD. Where this P I put 10, where this X I put 110. Just put that in the calculator. So it's going to be 3 times 10 sine 110 plus cos 110. Right, and this is root 2 times sine 110, and you're gonna get that is let me see, 3 times 10 sine 110 plus cos 110 times, yeah, so you're gonna get that as almost 13.49 units. So that's the distance of CD. So again, how do you then calculate this? We say then the area of a triangle triangle ADC is equal to half of length AD times the length DC or CD times sine of angle D. Okay, and this is half times the length of AD we know is 30, and the length of CD we know is 13.49, and we know sine 45. Okay, then you can just punch this in your calculator. So already have 13.49, so you can just times this by 30 and times it by half and times it by sine 45, which is 1 over root 2. And your answer is gonna be 143.1, depending on how far you wanna go, but let's say 111 units. So yeah, so that's gonna be your answer, and you get a mark. This is 3 marks, so you get a mark for essentially calculating, getting an answer and doing the substitution and calculating this half mark and this half mark for substitution. So yeah, so that's basically how you do it and get your all marks, 3 mark. And yeah, so this is 10 marks. Let me know if you have any question on this problem, and we've pretty much answered all the questions. And so if you have any further questions, let me know. I'm happy to help. I'm happy to jump in. I'm happy to show you how to do this. And feel free, if you're a new member, feel free to like and subscribe, and make sure you hit the notification bell so that you'll be the first person to know when I'm posting. But other than that, I'm posting every 5 p.m. On Monday, I'm posting on my Facebook page, just giving you the notes of this, and on Tuesday, I'm posting at 5 p.m. and again, take a break on Wednesday, and on Thursday, I'll give you the notes again for this following video that I'll be doing, and on Friday, I'll post the video again. So just check it out. Check my TikTok for short format of these videos. Yeah, and check the Facebook if you're not on Facebook. Check the YouTube if you're not on YouTube. All this content is found there. I'm happy to help you, and this content is built for you. So let me know if you have any other questions or anything that you want me to do or add, subscribe, or or emphasize. If you have any other question you want me to do, I'm happy to help you do well in mathematics. Boom.